Good day again, students. It's time enough now. We've been out a week, no videos done because we have finished all that we need to cover for the C6 syllabus, C6 syllabus with Pascal programming. All right. Well, I should say that was an error. I should not say it's on the C6 syllabus because it's not on the C6 syllabus. Because the truth is, on the C6 syllabus, they're only testing you to see if you understand the concepts of programming. They are not going to assess if you can write Pascal code or C or C++ or VBA, any particular programming language. You only want to see if you have an idea of how to write code. So we're finished with that. And we use Pascal because it was the old syllabus, many persons got seasoned in it, and some teachers prefer to actually use it to give you guys a good idea how to write code, one, and two, Pascal is closer to C programming that you'll use if you decide to go to university or college and further your knowledge with programming. But there are different ways we can solve problems or execute, not really execute, solve problems on a computer or execute tasks. We can use algorithms to indicate how we solve the problem. Of course, you can write the program, which is actually solving the problem, implementing the solution. We can use flowcharts, which are, as you can see, is a representation of executing a programming task. And remember, I put this term sequence of instructions to make clear, so you remember it is still software, on a computer by using shapes. Alright, so parallelograms, squares, or should I say rectangles, rhombuses, all of those different things. Alright, which is what I want to focus on today. So a flowchart is only another way of representing solutions to a problem. That's all it really does. And I think flowcharts are easy and they're fun. Just take a little bit of time, especially when you have a program like Word and you don't like 3D Draw or some program like that to help you with flowcharts. But flowcharts are extremely simple. But for that, we need to set a few foundational principles. Number one, you need to be clear on input and output statements. All right. Input, basically, think of yourself as a computer. What would you use to get data into yourself? You would say read. When you're reading, you're getting data into yourself. So those are input statements. When you're putting data into a computer, so when you say read or input or let something be entered or something, let us say that a particular variable equals a number or equals something else, let's say a name, you're basically inputting data into the computer. Remember, a variable is a memory area that the compiler or the interpreter decides to allow you to name. All right, so that's what a variable is. While constants are more or less, variables are subject to change, but constants are where the data is not subject to change. All right, so input statements, and we can see them here, input statements here for general algorithm, also for Pascal, and output statements for algorithm of a Pascal. So, and it doesn't mean that you can't use read line and read in Pascal, or in algorithm I should say. You can use those terms because remember, algorithms are simply just a representation. It's not really what's your executable, and it's just to give you an idea of how you go about solving the problem. So input statements, anything that gets data into the computer, while output statements get data out. If you remember back in the day from when you were doing input and output devices, you had the term input separate from output. Output meaning the data you're getting out, while the output device would be the machine to get the data out. Fair enough? So output device would be like a monitor or a printer. You're using those to see what you have entered into the computer or so forth. So the output device gets the output out of the data out of the computer, right? So what we're saying, the output statements are those terms, those words like print, display, show, write, write line. Those get the compiler to display the contents of a variable or a constant, or to show up simply message on the board, which if you went to the Pascal videos and the algorithm videos, you'd have seen quite clearly how these words come into play. All right. I find it more effective to teach flowcharts after I teach algorithms or programming. You know. because I don't like just imagining what would happen. You know, you should see and know, be able to relate to it. All right. All right. It should also be noted that input statements also store. So if I were to say, for example, read 3, all right, or read age, for example, let me say read age, what would happen there is that I'm going to enter a number into a variable called age. So you're storing a number. Let us say the person say I'm 15. So therefore, 15 will be stored into a variable called age. All right. All right, and I kind of make sure to reinforce that, meaning when a constant or a variable is assigned to a memory area, all right, that variable becomes storage for that data. In other words, you can store variables into variables. You can store variables into constants as well, once you don't want to change anything in that variable. That happens as well, depending on the programming language that you're using, and so forth. But let's get more into flowcharts now. All right, stop all the preamble. Now here are the flowchart symbols. All right, you have an oval here. And once you have stop, start, stop, begin, end, these terms, you can put start, end as well. Doesn't mean you have to use them in this way. Start, stop, begin, end. You can use start, end. All right, you can use begin, stop. Doesn't matter. All right. Once you have these terms, these words here anywhere in your program, or basically the start of your program at the end, you use an oval. Parallelograms, all right, this shape here, all right, kind of slanted like a rectangle, kind of skewing to the more toward the right. What happens is that in a parallelogram, that's where you're getting data into the computer or getting data out. All right, and for those who use words like let, input, read, write, display, even an equal sign. So if I say, for example, sum equals 0, you're entering 0 into sum. So at that point, you're using a parallelogram. All right. Now a process where we're going to be doing calculations, and we only have really 4 calculations in our human math points. As human beings, we only use addition, subtraction, division, divide, multiply. So whenever you see these symbols in a particular line, you know that you're going to use a rectangle. It's for a process or calculation, as you see here. When you want to make a decision now, you're not doing a calculation, you're trying to decide, is one variable equal to another or equal to a number? Is it greater than? Is it less than? Is it not equal to? And by extension would also mean, is it less than, not equal to, or greater than or not equal to? So less than or equal to, or greater than and equal to. All right, so that's basically what we do. So whenever you see a relational operator or a comparative operator, you know you're using a rhombus because a decision needs to be made. If this is, right now it's raining outside, so if outside equals raining, right, that's a test. You're evaluating something. See if outside means rain, because with the sun it could be snowy. We're in Jamaica, so it never snows here. All right, so whatever the variable outside is equal to, you're testing that. You're not doing a calculation. That's a rhombus. So whenever you have these shapes here, it simply means that you put those that will be related to a rhombus. And of course the connector, which we're going to be using a little bit from this, but not today. And we have the data flow arrows. Kind of challenging, use shift and control to get them as square as possible. Not always so easy in Microsoft Word. But here are the data flow arrows. These indicate the direction or the flow of the process through the program, through the computer. All right. All right. So right here now we have this simple little program that we use in our Pascal program at one point in time. Yeah. Simple little program here where we simply want to get 3 test scores. That's all I want to do. Prompt the user to enter 3 test scores. So enter test 1. All right. The computer read test 1 into the variable called test 1. You write again to the screen, enter second score. The person enters another number that is entered inside the variable test 2. And then they enter a final score, and that will be the third score. and then we enter now that number inside the variable called test3. Now that we have gotten all of this input, and I use the term input deliberately, now that we have all this input, now we can start the process. And the process, indicated, I'm hinting IPO chart there. Alright, so the process now begins here where we say now, sum is going to be equal to test1 plus test2 plus test3. We're adding them up. And then the average is going to be the sum divided by 3. Simple as that. And then the output now, the final part of our IPO chart, we're only outputting the average, not the sum. Alright, so this is a simple, straightforward, procedural program, if you want to call it that, whatever the case, a simple program that we're going to be doing a flowchart for. Now remember the shapes up here. Alright, so let's get going now. As per usual, we start with an oval. Alright, we have begin, so we have begin here. We can put start here if we wish, not a problem. The next line here, write line and read line, some persons would insist that you have separate shapes. For me, it's fine to put both of them in one because they are both relating to each other, directly relating. So enter first score, read test1. Alright, so you put those in parallelograms. Alright, so some person would insist that you'll say enter first test score, that's one parallelogram, read test1, there'll be another parallelogram. I don't insist on that. That's up to you and your teacher to decide. I definitely would not say that, since these are all, what should I say now, 6 input and output statements following consecutively, that you have one bit the problem. No, that's the height of laziness now, yeah? Don't do that. Alright, so that is one parallelogram here for this line of code. Enter in the first test score. This is the first parallelogram here. The second parallelogram relates to writing to the screen, enter second test score, and reading the second test score, storing that number into test2. So that's the second parallelogram. And the third parallelogram is likewise. So you simply draw these lines. Normally you draw them with a pencil on in your books or on a full leaf or your exam paper if needs be. So simple, start with the oval, and right away you start entering data. Alright? So parallelogram, enter the first test score and reading it. Another parallelogram, read the second test score. Alright, our prompt the user to enter second test score and then read that into the variable test2. Then prompt the user again, enter third test score. Alright, and then read the third test score by put whatever number the person enters and put that into test3. That's it. So there are our 3 parallelograms. Alright, I would insist you use at least 3. Don't use 1. Alright, okay, then now that we are through with that, we have one item, and I should adjust this because the truth is we have, I should change it to sum, sum, and remove the bracket here because I should change this a little bit because I did modify the program a bit. Then delete this and then put avg colon equal to sum divided by 3 and put the semicolon since we're using semicolons in Pascal, right? Just to pacify anybody who has a problem thinking that, oh, don't put the semicolon. All right, so this represents now exactly like what we have here. The process is done here, and if you notice what happens here, we're using now a rectangle. Rectangles are used for calculations. So we're using additions here in this line and then divide here. And here we are, additions, and then we're using dividing. So for to represent these 2 lines, we use a rectangle. Now we could use 2 rectangles. Again, some teachers might prefer that you use 2. I have no problem with you putting 2 or 3 processes that following consecutively, one behind the other, immediately behind the other in one. I wouldn't suggest you use more than 3 in one. If we had more calculations, put 2 or 3 in one rectangle, then 2 or 3 in the other rectangle. That's just what I think, to save time, because we know what we're doing. We understand what we're doing. All right, and then the final analysis now, we display to the user, right line, your average score is, so display to this user, put on the screen, your average score is average. And now we have the final parallelogram because we're now outputting something to the user. Your score is average. And then we end with another oval. Simple as that. There are no branchings here. We do that when you're doing selection statements like if. No branching, no looping. It's a simple, straightforward flowchart. Nothing complicated here. Alright, as you can see, it's as simple. Just draw the oval right begin. Then you check your program. Oh, I'm outputting something and I'm inputting something. So once you're using input or output, you use a parallelogram. Simple as that. And now we have 3 sets of parallelograms. Alright, 3, 1, 2, 3. To represent these these pairs, 3 pairs of input output statements. Alright, instead of writing 6, we just did 3. Alright, and then here we use a rectangle because we're doing a calculation here. We're doing additions, addition, and then we are dividing. So once we're doing addition, subtraction, division, multiplication, we use a rectangle. And then we're outputting something to the screen again. So therefore we use a parallelogram because we are writing to the screen. So we use a parallelogram. And then the final analysis, we use a oval because the program has ended. This is not the end or stop. That's it. Nothing more, nothing less. It's simple. I mean, flowcharts are easy like cheese to use, all right, or to create. So what I'm going to be doing next time, I'm going to 2 more videos. Want to show you how if statements work, and I will have one to show you, hopefully, just regular branching if statements, and then consecutive if statements, and then we'll have another to do loops, and then that's it for flowcharts. I mean, flowcharts are easy. All right, so I hope you have a good day, guys. I hope that works for you, and have a good day.